So in the last class we discussed about the ways of by which logical implementation of a communication link can be established. So by three ways we can establish a communication link. One is direct and indirect communication, synchronous and asynchronous communication. Third one, automatic or explicit buffering. So first let us look into the direct and indirect communication. So the disadvantage or an issue issue as associated with direct and indirect communication is naming. So naming means the process that want to communicate must have a way to refer to each other. Okay, that is they have to name. We have to have a name for the sender process as well as for receiver process, or the identity has to be there. So they can either use direct or indirect communication. So first let us see what a direct communication is. There are two variants of direct communication. So first variant is each process that wants to communicate must explicitly name the recipient or sender of the communication. They have to give the name for the sender process as well as the receiver process. Okay, and then they can use the two operations, send operation and the receive primitive for sending and receiving the messages. So here you can see that we have a send primitive, send p comma message. So the meaning is that send a message to process p, and next is receive primitive. So you can see receive q comma message, that means receive a message from process q. So we can see that here the name we have explicitly specified the name P and Q. Okay, so that is direct communication, and the properties of the communication channels are listed below. A link is established automatically between every pair of processes that want to communicate. So the link is established automatically here, and a link is made between exactly two processes, between a sender and receiver, and between each pair of processes there will be only one link, or there exists only one link. That is a property of communication link used in this scheme. And the another variant of direct communication is as follows, that is here the sender will only sender names the recipients, okay, and the receiver may not name the sender, only the sender will name the recipient. And so here you can see that we have the send and receive operations here. So send p comma message, that means send a message to process p, and receive, here you have id comma message. So we doesn't have a name here, we just have a variable called id. So since it's a variable, each and every time the value may change, right? So that is receive a process from any process, receive a process from any process, so that is id. Now this scheme actually employs an asymmetry in addressing. Asymmetry means here only the sender names the receiver, and the recipient doesn't name the sender. That is meant by asymmetry in addressing. Okay, and the disadvantage in both of these schemes, okay, whether it is symmetric or asymmetric. Symmetric means the first variant of indirect communication, asymmetric means the second variant of direct communication. The disadvantage in both the cases is that limited modularity. Limited modularity means process communication with each other using process communication happens using the names of processes. If the identity of the process is changed, suppose if we change the name from P to some X, then we have to do a lot of operations, okay, that is we have to check all the process definition including the which includes the name P, and we have to change it to some X. Okay, that is a disadvantage, limited modularity. That is, if we change the name from P to X, then we will have to make the changes wherever the P is listed, where they are all, we have to change it from P to X. So that is the disadvantage, limited modularity. Next we move on to second type of communication, that is indirect communication. So in indirect communication, messages are sent to and received from mailboxes or ports. So this mailbox can be viewed as an object into which the messages can be placed, and from it can be removed also. And the specialty of mailbox is that it has a unique identification, so it can be identified uniquely. For that we will have a unique ID for that two processes can communicate only if they have a shared mailbox. That is, if process A and B want to communicate with each other, then they should have a shared mailbox. Okay, then only they can perform send and receive operation. So here you can see we have two primitives, send and receive. Send a comma message means send a message from message to a mailbox A. Receive a comma message means receive a message from mailbox A. Okay, so you have a mailbox, so you can see we have a mailbox A over here, and both the sender and receiver will share the mailbox A. Okay, so one can send the message into the mailbox and the other can read the message from mailbox. Now suppose that process P1, P2 and P3 all share a mailbox. Okay, you can see here we have a mailbox named A, and P1, P2 and P3 are associated with this. Okay, they all share the mailbox. Suppose P1 is sending a message to A, and P2 and P3, okay, will receive it, right? Because both these are connected, they have to receive the message. Now which process will receive the message sent by P1? Okay, P1 is sending the message and there are two other processes sharing this mailbox. So who will receive the message first, or who will receive the message sent by P1? That is a problem. So it depends on the following methods that we choose. Okay, so allow a link to be associated with two processes at most. Okay, so the solution for this, or we should allow a link to be associated with two processes at most. Okay, allow at most one process at a time to execute a receive process. The solution is that allow a link to be associated with at most two processes. Okay, so that we'll have a sender and we'll have a receiver. So when one sends a message, the only one receiver is there and it will be delivered to the receiver. Allow only one process at a time to execute a receive operation. Okay, or we can choose a method such a way that only one receiver can receive a message at a time. Or the next solution is to allow a system to select arbitrarily the receiver. Suppose there are different receivers, then the system will choose which have to receive the message. Okay, and the sender is notified who the receiver was. That is by using the round robin algorithm or something, the system will implement this. So this is a solution for that. And a mailbox may be owned or by a process or by an operating system. So it is on, if it is owned by a process, then when the process terminates, this mailbox will also terminate and it cannot be used further. But when the mailbox is owned by an operating system, then it can be used further. Okay, when two processes communicate with each other, and if their communication is over, then it can be used by other processes in the future. So that is the benefit of owning a mailbox by an operating system.